Hi there! Welcome to Explain This, a podcast where we try to explain complex things in simpler ways for people of all ages. I'm your host Jin Kim, and today we'll talk about entropy and how the heat death of the universe is coming for us all. Let's get started. If there's one universal truth in life that I've learned in my 3 decades of life, it's that the entropy of an isolated system never decreases over time. Wait, what? You may have heard of entropy in science fiction stories, or people using it as an excuse for not cleaning up their messy rooms. Or you may remember something about the second law of thermodynamics, or something like that. Well, today we're going to learn all about what entropy is, and how learning about physics can help motivate you to actually get things done. So first, let's explain entropy to you as if you were 5 years old. Imagine you have an awesome Lego spaceship. It took you the whole week to build this massive, intricate feat of engineering, and just put it on display in your room. Hooray! But then your jerk of a little brother knocks into it, and the spaceship comes crashing to the ground. Oh no! You can imagine what would happen next. The tens of thousands of Lego pieces that you painstakingly assembled in perfect order to make the ship, they'll just crumble like dust, scattering the pieces all over your bedroom floor, making it a minefield for your bare naked feet. But why? Why do the Lego pieces always shatter and scatter? Why do things always tend to get messy and disordered? Can't we get lucky just one time and see the Lego pieces pile up neatly into an organized heap? Even better, if everything happens randomly in the universe, why don't we ever hear of cool stories like the Lego pieces just happening to sort themselves perfectly by color, or assembling into a different kind of spaceship? Oh, silly Billy. If only the laws of physics allowed for this. Unfortunately, entropy means that everything will become more chaotic and disordered as time goes by, but never the other way around. You, the universe, and everything you care for in it are going to die and fade away into nothingness in the face of time. Happy birthday, kid. Enjoy your Lego. Ah, yes, after a week of coziness and warm, fuzzy feelings, we're right back in our comfort zone by talking about the inevitable cold embrace of death. But before we get too far ahead of ourselves talking about the eventual heat death of the universe, let's talk about entropy. Now, like many other science concepts, the true definition of entropy is quite dry and technical. Something like the measure of a system's thermal energy per unit temperature that is unavailable for doing useful work, according to the Encyclopedia Britannica. But fortunately, we're in the business of explaining complex concepts in a way you can understand, so let's reframe entropy with actual English words. The simplest way to imagine entropy is a hot cup of coffee. A hot coffee has a lot of heat energy to start with. But over a long period of time, like while I'm writing a podcast script for example, the coffee will cool down. The concentrated heat energy in the coffee starts to spread out into the table and the air around it, sharing the love, so to speak. Eventually, the heat energy evens out so that the coffee, cup, the table, and the room air are all the same temperature. This is an example of entropy. Essentially, you can think of entropy as a marker of how chaotic and disordered the system is. A hot cup of coffee is very ordered. All the heat energy is concentrated in that one spot. But when it cools down, the heat energy is scattered all over the room, which is disordered. You follow? Think of it another way. A cup itself is a very beautifully ordered structure. But when you drop it onto the floor and it shatters into pieces, it's very disordered and chaotic. If you live in the real world, you know that a cold cup of coffee will never heat up on its own, nor will a bunch of broken glass pieces magically reassemble themselves into a cup. You need energy and effort, like a microwave heating up the coffee, or you physically repairing the cup to reorder things. Time always marches forwards, and things only get more chaotic and disordered with time when left alone. This is the second law of thermodynamics, a really important physics law that has held true since its discovery and much longer since before that, as far as we know. It states that in a closed system, with no intervention or outside interference, entropy is only going to increase with time, or stay the same, until an equilibrium is reached, a state of maximum entropy. Essentially, the entropy will never decrease. Things will never become more ordered unless the system is opened up or something is introduced into it. Let's use some more examples to highlight the difference between ordered systems and disordered systems. A full glass of milk, ordered. A spilt glass of milk, disordered. A fresh set of bowling pins arranged in a triangle, ordered. Scattered bowling pins after a beautiful strike, disordered. A fully charged battery with plenty of juice, ordered. A flat battery, disordered. Humpty Dumpty on the wall, ordered. Humpty Dumpty shattered on the ground, very disordered. Now you might be noticing a trend here. An ordered system is where you have managed to concentrate energy and matter into one neat location in a nice structured way, like heat in a cup of coffee, or milk contained in a glass. Entropy is when this order breaks down and the system is more disorganized, chaotic, and random. And it always goes in this order, never the other way around. I mean, think about it. A cracked egg won't reassemble itself, a spilt glass of milk won't pour itself back into the glass, and dead batteries won't recharge without you plugging it in. Even the word entropy comes from the Greek word for transformation, as in things are transforming into chaos. So why is this the case? Who set this bizarre rule in the universe? Wouldn't it be amazing if your messy room could just neatly organize itself without you having to do any work? Let's take a short break so you can take a breather, and when we come back, we'll talk about how entropy actually works. Welcome back. So we talked about how every system becomes more chaotic and disordered over time due to entropy. But technically speaking, entropy is a bit more than just how chaotic something is. It's actually more to do with possibilities. Let's get down to the really little details. I mean, really little. Like atoms. In the molecular world, time works differently to our world. In our world, spilt milk won't magically pull back into a glass, so we should never cry about it. But in the molecular world, being spilt just means that the milk molecules are more spread out, rather than concentrated in the cup. There's nothing really stopping the molecules from moving back towards the glass. I mean, it's just another direction. Let's simplify it by a lot. Let's say you have 3 different colored balls, red, green, and blue. Now, how many different ways can you arrange the 3 balls? Say, if you were to pick one ball out at a time from a bag that you can't see inside. Well, you could have red, green, then blue, or red, blue, green, or blue, red, green. All in all, you'll have 6 different possible ways to arrange the balls. So it turns out entropy is just a fancy way of saying the number of possible arrangements. If you want a specific order, like red, green, blue, then it's only one possible arrangement out of 6. But if you don't care about the order, as in disorder and chaos, then you have 6 possible arrangements. Therefore, a disordered state is just statistically more likely than an ordered state. This is essentially why entropy always increases rather than decreases. It's just statistics and maths. But aha, you'll say, what about that 1 in 6 chance where you do get the order you want? Doesn't that mean there's always a chance that entropy might decrease? Well, technically, you see, the way statistics works is that the more variables and bigger the number of objects, the less the chance of a specific outcome is. I mean, we were talking about just 3 balls now, but if you have 30 balls, the chances of one outcome is already 1 in 265 billion. And you have a lot more than 30 molecules in a glass of milk. So when it comes to our macroscopic world, the chance of order is infinitesimal, like very, very, very close to 0 to the point that it's negligible. It's less likely than a monkey playing with a typewriter somehow perfectly typing out Shakespeare's Hamlet, or a pile of cogs being thrown on the ground and magically assembling themselves into a pocket watch. Statistically speaking, disorder always wins, because it's just much more likely to happen. There's a much, much larger number of possibilities of energy being spread around, rather than having it confined to a specific place. Like, if you scatter a jar of marbles on the ground, there's many, many more ways you can randomly arrange those marbles on the room floor compared to when it's just all bottled up in the jar. So there's no magical agent of chaos telling molecules and systems to be more disordered and for entropy to increase. It's just stuff obeying the laws of random chance. This is entropy, and this is why death is coming for us all eventually. Oh, there it is. I was wondering when the whole death part of the podcast would be coming for us. Alright, now that we have a better understanding of entropy, and the fact that it always increases unless extra work is done as per the second law of thermodynamics, we can talk about how the universe may end. Heat death. You see, even if we ignore all of the horrific, bizarre ways the world may end, like supervolcanoes, rampant pandemics, the moon crashing to the earth, gamma bursts and false vacuum decays and supernovas, oh my, there's still an eventual expiry date for the universe. Entropy applies to everything in the universe, especially energy. The universe kind of functions because energy is in various forms and in different concentrations. For example, the sun is a massive store of nuclear energy, showering us with heat and light so plants can turn it into chemical energy, which we eat and turn into mechanical work, etc. But along this chain, nothing is 100% efficient, so we lose some energy as wasted heat. Like how a light bulb is really hot when it's turned on. That energy will just dissipate and spread away into the room, just as we talked about with entropy. Eventually, in the long, long distant future, thankfully, all energy in the universe will be wasted. Eventually, the last star will burn out, and all energy in the universe will be in the form of evenly distributed heat. No work would happen, nothing would move or be alive, and everything will just come to a standstill in a tepid bath of even energy. This is the heat death of the universe, the final step of time. This is the state of maximum entropy in the universe. It's just the inevitable end for a universe thanks to entropy. So before you ask the genie for immortality, think about that. I mean, you may end up spending infinite amounts of time in a very, very, very boring still universe. If you have a free hour or two to kill, I highly recommend reading a short story by the great sci-fi author Isaac Asimov called The Last Question. It's an excellent short story about entropy and whether we can ever meaningfully reverse it. But yeah, that's the heat death of the universe for you. But don't worry, you'll probably die a long, long time before that even happens. Because your body is also a system undergoing entropy. Your cells are doing their darn hardest to fight against entropy. It burns food to keep fueling the little machinery that keeps everything balanced in your body, while retaining and producing heat, repairing damages, and constantly trying to reorder things. But eventually, entropy and chaos and disorder overcome our body, until our cells stop functioning. Then finally, the cold embrace of death takes us. Literally. We go cold and stiff, get buried in the ground, where we slowly turn to dirt and dust. Spoiler alert, ha! Well, that was a very depressing section on how everything will eventually end, one way or another. Let's finish this episode on a more positive note by discussing how learning about entropy can make life better, rather than worrying about the inevitability of death. Now, as we've mentioned over and over, every system in the universe obeys the laws of thermodynamics. There's just no escaping from entropy, like our bodies decaying over time until our death. The same could be said of our brains. If we leave our brains alone, it will default to the lowest energy state. You've probably experienced this on holiday or when you're feeling particularly unmotivated because you're going through some kind of funk. It's the kind of mental state where you just passively consume content, like binging a TV show without following the story, or doom scrolling social media, or procrastinating for hours on end, with absolutely no productive work done at the end of it. But don't be too harsh on yourself though. Like I said, it's pretty natural. At the same time, just because something is natural doesn't mean it's excusable. I mean, monkeys are pretty natural, but you don't see people flinging poop at each other, often. The same could be said about cleaning up a messy room or wiping your freaking butt after you poop. Just because entropy has a tendency to increase doesn't mean we can't or shouldn't fight against it. Hell, your body is fighting against entropy every second, trying to keep you alive. So do it a favor and kick your brain back into gear as well. But how, you might ask? How can we decrease entropy in our brain and be productive when we just spent the last while talking about how increasing entropy is inevitable? Well, the secret is to actually reading the full second law of thermodynamics. It says that entropy increases in an isolated, closed system. This is the secret. This is the reason why we can clean up a messy, disordered room or reheat a cup of coffee. A closed system is essentially a system where you're not adding any work or energy into it. For example, you can turn a heater on to heat up a room, turning it from a closed system into an open system. The antidote to entropy is work. So how do we apply this to our own brain? How do we stop our brain from being an isolated system? Well, here's 3 big ways you can do that. First, stimulate yourselves. Oh my. No, get your mind out of the gutter, not in that way. I mean, put some heat in your life and reheat that metaphorical cup of coffee. Find something you're passionate about, like hobbies or interests, or learning new skills or new knowledge. Our brains love to be fueled by curiosity, passion, and experiences. So the more you expand your horizons and fuel your brain, the more energy it will have to use for other things, like being productive. Second, connect with other people. Open up your brain by sharing experiences and conversations with people you enjoy spending time with. Healthy social interactions help ground us to reality, while inspiring us to be better versions of ourselves. This is a great way to introduce new knowledge, insights, wisdoms, and love into your life. A great source of energy. Lastly, and most importantly, you need to channel your own willpower. Our natural instinct is to be lazy and procrastinate. It's just the easier, statistically more likely state. So we have to fight against it by pushing our lazy butts out of the couch, so we can exercise, work, create, produce, and live. I mean, I know this is hard because it's like me telling you to just do it, Nike style. But it's not impossible. You just have to find ways to make it easier and more automatic by finding systems and brain hacks that work for you. So whether it be finding time intervals like a Pomodoro system, motivating yourself with little treats, having a routine, or gamifying your life to create good habits, find ways to trick your brain into being productive. And with these 3 secret tricks, you'll find yourself auto-adjusting your life to prevent entropic laziness from taking over your life. If you read the Asimov short story, The Last Question, that I mentioned earlier, you can see how even a supercomputer can't figure out how to meaningfully reverse entropy in the universe. But when it comes to our own brains, turns out all you have to do is put in some effort and work, and we can do the seemingly impossible. I know, it's not really the same as preventing the heat death of the universe, but it might help you live a healthier, more productive life, and that's pretty damn worth it. Well, let's wrap it up there before I start rambling about how nothing in life really matters because all of us in the universe we live in will die eventually. So, what did we learn today? We learned that entropy is a measure of how chaotic and disordered the system is. We learned that actually, entropy is really the measure of how many possible arrangements you can have in a system, and how disorder and chaos happens to be the statistically most likely outcome, because it's so unlikely to have everything neatly ordered. We learned that in a closed, isolated system, entropy never decreases over time. So eventually, all the heat and energy will equilibrate in the universe, and it will undergo what's called heat death. We learned that entropy affects everything from a cup of coffee to our body, but most importantly, our brains. Lastly, we learned that the secret to fighting back entropy and laziness is to introduce work and energy into the system. So, stop being lazy and force yourself to do something productive today. Well, that's it for today. Thank you for listening to Explain This. I hope you learned something interesting and maybe even useful today. Something that you can use before the cold embrace of death eventually comes to you. We'll see you next time. Bye for now. Explain This was written and hosted by me, Jin Kim. If you'd like to suggest a topic or just send a lovely message, you can email me at explainthiscast@gmail.com or follow me on Facebook or Twitter